Hey Internet, Gordon with PCWorld here. Yesterday is finally here where you can see third-party reviews of AMD's Ryzen AI 300 series. It is basically the company's best and brightest laptop SoC. You can see it on the screen right behind me. If you don't know what it is, quick summary, you can look at a video on our website getting into the guts of the Ryzen AI 300 series, but you can also see the chip right here. It basically combines four AMD Zen 5 full performance cores alongside 8 Zen 5 cores with less cache or compact versions of this. That basically gives this SoC 12 CPU cores in a monolithic design, and of course that is paired with the brand new Radeon 890M graphics as well as the latest FPGA for all the goodness for the AI performance as well. But let's kick this off by looking at how we're going to look at this chip, because you can never actually separate the chip from the laptop itself. So we're going to be looking at this Ryzen AI 9 HX370 specifically in the brand new Asus Zenbook S16. It is a 16-inch laptop using a Ceraluminum. I don't know what it is. Ceralumin body that is just wonderfully exotic. It basically uses ceramic and plasma and aluminum to give it a really, really luxurious feel. You can see that this laptop just looks simply beautiful. Here's a side view of it, and of course another top view of it. And I know a lot of people get confused because they look at a laptop with a 16-inch screen and they go, well, this is a gaming laptop, right? Because these big laptops, that they're meant for gaming. Well, this laptop has fairly decent gaming chops. I'm gonna say this really is not what I would call a classic gaming laptop, because basically it doesn't have discrete graphics. Again, it does combine that Ryzen AI 9 HX370. You can see it in the first column here with Radeon 890M. But this is really a classic integrated graphics laptop. There is no discrete graphics. There's no discrete Radeon. There's no discrete GeForce. And to me, that really makes it an IGP laptop, classically what you would find in a 13.3 inch, a 14-inch thin and light laptop. But in this case, you get a great big gigantic 16-inch 2880 by 1800 Samsung OLED 120 hertz touchscreen with pen support, which comes with a pen as well. So it is essentially a thin and light laptop that gives you a luxury feel, is fairly light in your bag, and but is not going to be made to be gamed on all day, because frankly, I think we would all agree if you want to play games all day, you want to pony up for a laptop with discrete graphics, with discrete Radeon. Of course, AMD would like you to do, or from NVIDIA, they would like you to do a discrete GeForce. That just simply gets you better performance in the latest games, and that's generally what you want. But I think a lot of people get confused because when they see a great big 16-inch screen, they go, oh, automatically gaming laptop with discrete graphics. This is not. This is more of a IGP laptop, and frankly, I think it compares nicely with these other two laptops, although I do admit it's not perfect, but those are the laptops I have on hand. And of course, in the middle column is the Zenbook 14 OLED, also made by Asus. That has Intel's Core Ultra 7 155H with ARC graphics. It is basically Intel's best and brightest SoC as well. And of course, it goes up against the Microsoft Surface laptop with the 13.8-inch, let's call it 14-inch screen. Microsoft Surface Laptop 7. Again, these are all very much what I would consider IGP laptops. And the big difference is not only the discrete graphics, but also the weight. Because look, the Surface Laptop 7 is 2.96 pounds. This Zenbook S16, despite the 16-inch screen, is 3.3 pounds. So actually very, very close in weight to that Surface Laptop 7. And if you go up to the Surface Laptop 7 with the 15-inch screen, then basically you have similar weight, and they are very similar laptops. Again, IGP laptops. And again, looking at that Zenbook 14 OLED with the Meteor Lake, that is just under 3 pounds. So again, very, very light in your bag. If you were to put in discrete graphics, even into a 14-inch content creation laptop, you're still looking at easily 4 4.5 pounds if you're lucky, and that's not counting the 200 or 230 watt power bricks in them, which add a pound to a pound and a half to 2 pounds. And all of these laptops run on very small power bricks. Look, the Zenbook S16 has a 65 watt USB-C power brick. The Zenbook 14 OLED has a 65 watt brick, and the Microsoft Surface laptop has a 39 watt power brick. Basically very light in your bag, and you simply can't say that for content creation laptops. Yeah, they're fairly light, but you have to eat a big power supply, and the laptops themselves just simply weigh more because it takes more cooling to keep the discrete graphics powered and cool for most of the time. So I think the comparisons are fair. Yes, it would be fair. I agree. It would be fair to have a Meteor Lake laptop in a 16 or 15-inch body with a Core Ultra 185H. AMD would disagree because that is a 45 watt TDP part. The Ryzen AI HX 370 is actually, I believe, a 28 watt TDP part. So, it gets really weird, but these are, for the most part, very light IGP laptops, some of them with big screens. And I guess if you were to look at a fair comparison to the Zenbook S16, it would probably be the MacBook Air 15, which basically is a laptop made for you to just type and browse and do kind of like basic computing all day. Decent power still, yes, very, very, very good laptop. But again, it's not a pro. You're not getting the high-end discrete graphics. So that is a demarcation line. I just want to point that out because a lot of people, when they see 16-inch screen, they automatically think discrete graphics, big laptop. So I got to make sure you understand that. And yes, I wish I had a larger Surface Laptop 7 as well as a larger Meteor Lake laptop to compare it to. But still, these are really good points of reference. So, but let's get into the numbers. Let's kick this off where we usually start off, which is Cinebench. This is the 2024 version. We are running NT, or basically multi-core, all-thread versions of the benchmark here. Red is AMD, and surprise, surprise, the laptop with the highest Cinebench 2024 score is the Zenbook S16 with the Ryzen 9 HX 370. Again, that is 12 cores. I actually think that's pretty impressive because I thought this would be a little bit slower. It would be closer to that 12-core Snapdragon X Elite as well as that Core Ultra 7 because, again, it's going up against, for the point of reference, I'm throwing in scores that I also obtained for the Zenbook Pro 14 OLED with a very powerful 45-watt Core i9 13900H, that's a Raptor Lake part, as well as a Razer Blade 14 with a Ryzen 9 7940HS. And that is the 8-core Phoenix in there. Those are, again, content creation laptops, very powerful. And if you want to run them all day, they generally outperform other laptops that are in thinner laptops. But we see in Cinebench 2024, the Zenbook S16 is the tops. Not a big advantage over those content creation laptops, but still, it's the first to cross the finish line, which you got to give it its props for. And against the Snapdragon X Elite X1E80, of course, that is, I think, one step down from the top end X1E84. It's about a 13% advantage over that Snapdragon X Elite, which is a very impressive fast laptop with its 12 cores. And it's, of course, 44% faster than that Core Ultra 7 155H. Yes, again, Intel fans, we know there's a 185H out there, but that is a higher TDP. But 44% is a pretty big step above that. I would love to see the 185H in a Meteor Lake laptop. Frankly, I haven't touched a lot of Meteor Lake laptops. Is it going to get that much closer to this Ryzen 9 HX 370? I'm not quite convinced it's going to step up that much, given how Meteor Lake has performed in this Zenbook 14 OLED. But this really is there for the point of reference. And, of course, for Mac fans or, Mac folks, the MacBook Air 15 with its 8 cores, 4 performance cores, 4 efficiency cores, gets stomped on pretty well to the tune of about 42% by the Ryzen 9 HX 370 with its 12 cores. And again, I know they would say, well, you should put this up against the Pro. I do have a score generated. Both of those scores are from Macworld. Both of those MacBook Pros with the M3s both get stomped on pretty handily by the Ryzen 9 as well as by the Snapdragon. And frankly, the Core Ultra 7 basically is running right up alongside those as well. So be that as may, let's go on to the next one, which is Cinebench single thread performance. This we are, instead of running on all of the cores in this, so it gets a little weird to go like I'm comparing 8 cores, 12 cores, 16 cores, blah blah blah. This is only looking at the performance of Cinebench 2024 using a single thread in all of these. So you can sort of take the core count disparity out of this. The winner, of course, is again that impressive MacBook Pro 14, MacBook Air 15 at 141 for both of those. And you're basically looking at about 25% higher performance over the Ryzen 9 HX 370 in single-threaded performance. But I think what's probably more important, though, is to compare to Phoenix, because we are looking at Zen 4 and that Ryzen 9 7940HS at 106 versus 113. That's basically about 6.5% higher performance going from Zen 4 to Zen 5. Some of that's in clocks, but some of that's also the improvements and the core improvements. And still also, of course, Qualcomm would like to point out they are still outperforming the latest Zen 5 in Cinebench 2024 to the tune of about 9%. And of course, AMD would say, hey, that's cool, but we're still outperforming Core Ultra 7 Meteor Lake by about 9%. So everybody's going to be pointing around at each other saying who they're faster with, not who they're slower with. So overall, we see a decent improvement for Zen 5 over Zen 4, which is worthy of pointing out, but still a little bit behind the ARM parts. And I do want to point out, of course, Raptor Lake with that very high clocks is also outperforming it in the Core i9 13900H. And the last caveat I'm going to point out is that Cinebench 2024 is like R23, a little bit of a weird world because on the ARM parts on Mac as well as on Snapdragon, you're basically running code written for ARM and its Neon instruction set. And on x86, you're basically running on AVX, some AVX2 for x86. So you're actually running on different code paths on both of these, which makes it a little weird. And it, of course, makes you go like, well, did they actually code the version of Cinema 4D for Neon as well as they did for the x86 version? I don't know. At the same time, a lot of people are going to say, well, I don't care. The only thing that matters is when I press go, I just want the frame to be rendered, so that's what matters. But anyway, let's keep going. Okay, up next is Blender. This is the open source 3D rendering tool that has gotten really popular. In fact, it's actually gotten fairly popular in Hollywood, too, because of the price. It's open source. It's free, right? People love that. And this is basically taking Blender 4.1. You can download that now using the Barbershop CPU scene. You can also download. It's out there. You can find it. Using cycles, we are rendering this scene on the CPU. I'm not using the GPUs here at all. It's also in seconds. Basically, the shorter bar is better here. The worst, of course, is the Snapdragon X Elite X1E 80-100. Part of that is, of course, is the current public version of Blender. The final published one does not run on ARM. It's not optimized for ARM yet. Who knows how long that's going to take because, frankly, it's not really that well optimized for AMD Radeon as well. So we'll see how long it's going to take for Snapdragon to catch up. But for the rest of the pack, though, again, Zenbook 16S with that Ryzen 9 HX 370 doing pretty damn good at 1458 seconds. That's it's taking about 40% less time to render than the Meteor Lake. Again, yes, we know there is a Core Ultra 9. There's a hotter version of it and a little bit bigger of a laptop. It's going to close it up. I'm not convinced it's going to close it up that much, but we'll see if I ever get my hands on a Core Ultra 185H laptop. But again, pointing it out, comparing to Ryzen 9 7940HS, this is Blender. Same thing, Blender 4.1 running on the CPU because I did want to see, well, let's see what happens. We run it on a Ryzen 9 7940HS. That's a higher TDP part in a laptop with much better cooling. And this is, again, a mostly all-core load, and it takes quite a bit of time to run. So I thought, well, I would think the 8 cores of Ryzen 9 Zen 4 might actually do pretty well. And frankly, it does when you consider that you're looking at 8 cores versus 12 cores. but you are again looking at the better cooling of a content creation laptop, and we're essentially slightly dead even. Yeah, Zen 5 and the Ryzen 9 HX is a little bit faster, but they're basically dead even. And also very impressive, Ryzen 9 HX 370 outperforming the Zenbook Pro 14 with the Raptor Lake Core i9-13900H in it. Again, that is a pretty hot part, literally hot. But again, it is in a content creation laptop. 14 inches, so a little bit smaller body, but it is thicker, but it has better cooling. It also, again, has a 200-watt power brick versus a 65-watt power brick. So this, I would say, is a very good showing for Zen 5, Ryzen 9 HX 370. And, you know, again, you take this Ryzen 9 HX 370 or the newer 375 part they've apparently announced, and you put it into a gaming laptop or a content creation laptop, and that's where we're going to really see it sing, I think, when you pair it up with even better cooling inside. So we'll see. We'll see. But in the meantime, again, I would say this is a very solid win for Ryzen 9 HX 370 and Zen 5 against Meteor Lake. Again, yes, we'll see against a hotter Meteor Lake, but Snapdragon not in this contest at all. Again, a lot of this is emulation, but big winner, Ryzen 9 HX 370. Let's keep going. So for the next test, we are going to basically do a CPU encode. Again, you could do this on the GPU. You could also use some of this on the independent hardware media encode circuits that each of these chips has built into it, although I'm not sure that Snapdragon X Elite is supported yet. But I chose to do this on the CPU itself. This is basically using SVT AV1, which is primarily started as an AV1 encoder. A lot of the work on this was put in by Intel. So they did a lot of the work to do the heavy lifting to do the encode on CPU, and you can also do it on the Meteor Lake quick sync part, which would slay everybody. But let's actually look at an all-core encode on this. And again, I would say versus the content creation laptops, again, very good showing, because those, again, those chips are pushing more wattage. They have better cooling. They have louder fans. They have thicker bodies. They weigh more simply. But again, the Ryzen 9 HX 370 is hanging right with the Raptor Lake, as well as that 45-watt Phoenix part in the Razer Blade 14. So good showing, although slightly slower. AMD would say, well, we think it goes up better against those IGP laptops. And yes, again, when you look at it there, again, Surface Laptop 7 with Snapdragon X Elite, about 25% less time to do that encode, and about 28% less time versus that Core Ultra 7 in that Zenbook 14 as well. So yes, it does. It obviously does outgun both of those IGP laptops. And again, very similar weight class, 3.3 pound to 3 pound. So I would say overall winner for Ryzen 9 HX 370 on this all CPU test. And this again, if you don't know, I'm taking the free open source 4K Tiers of Steel, and I'm basically using SVT AV1 8-bit, not using 10-bit and the main profile on this. So it takes quite a, again, look at that. That is in seconds. You want a shorter bar, but this takes a considerable amount of time to run. So you're really, really testing these chips if they're going to throttle because of the cooling, or they're going to throttle because they're going to everything they need more power. You will see it here, but Ryzen HX 370, good showing here on a very, very heavy CPU load. Okay, what's up next? Let's do something lighter because, again, Cinebench and Handbrake are all cores. The vast majority of things that you do in this world are not going to be using every single core in your CPU. I know the chip makers would like you to think that, but it doesn't. So we're going to look at the browsing performance using Chrome 126. These are on identical Chrome versions. I didn't break out the full version of Chrome, but this is on the latest version of Chrome. And yes, as we know, it updates like every 4 days. So this is on the same version on all of these laptops. And I actually ran 3 different benchmarks here. Speedometer is probably the one that's very popular. The actual winner is Snapdragon, to the tune of about 5% over Meteor Lake, as well as against Ryzen 9 HX 370. 5% is probably not a big deal, but if you're Qualcomm, you're going to be happy you won this because it's a browsing benchmark. But of course, everybody sort of likes to pick their browsing benchmark that they do better in. For example, AMD's been showing off, hey, our browsing performance is awesome on Zen 5 cores. Look at JavaScript performance in Kraken 1.1. And I know a lot of people are like, what's Kraken? I haven't heard of that. Well, it's probably because people probably have not used this JavaScript benchmark in, it feels like, 8 years. But AMD has busted this one out to say, hey, we're doing pretty well. And this is in milliseconds, so you actually want a shorter bar. And that red bar is the shortest. And they're about 13% faster than Snapdragon and about 14.4% faster than Meteor Lake. And here's where, again, this is a very light load. And I know people say, oh, well, Core Ultra 9 will do better slightly because you would get higher clocks. But this is a very light load. And other than the higher clocks, you're not really looking at pushing all cores on this. Same thing for Snapdragon here. So AMD basically is like, hey, we're really good at Kraken, so we're going to show that off. I ran this just to verify that's like, yeah, they have a very decent lead in Kraken. Again, is it a valid browser benchmark for 2024? I don't know, but a win is a win. My last browser benchmark is Principal Technologies Web Expert 4.0. I like it because it runs quite a bit longer. It doesn't only focus in on one thing. It has quite a bit of different disciplines that it runs. It takes about 5-10 minutes to run, and longer bar is better here. And surprise, surprise, Ryzen HX370 is the winner here at 348. They're about 10% over Snapdragon, about 6.6% over Meteor Lake. I will say generally, it does favor Intel. Because, Intel, look at the performance of Web Expert 4 is better than Snapdragon, but Zen 5 and Ryzen, gotta still remember this, Ryzen AI 9 HX370 is the tops here. So winner Ryzen in 2 out of 3 of these benchmarks. So overall, good performance by Zen 5. You're getting, obviously going to get very snappy browser performance out of Zen 5. And frankly, do I care? Because frankly, are you going to notice a difference? I would say no, but people like to see browser benchmarks for some reason. Okay, let's keep going. Okay, up next is something that is also fairly lightweight, but also, very real world. This is basically UL Procyon. You install Office 365 or a retail version of Office, and it runs the laptop or PC through basically a scripted demo to simulate Office use in Word, Excel, PowerPoint, Outlook. And what I like about it is it actually looks pretty realistic. If you actually watch this benchmark run, the actual test, it looks like something that a real person would do in PowerPoint and Word and Excel and Outlook. And also all 4 of the applications are running at the same time. So typically a lot of benchmarks, you run each of them independently to get sort of a cleaner feel for it. This actually runs all of these applications at the same time, and it alt tabs between them running something else. So like it types something in Word, it copies and pastes it, and then it copies it into Excel, it does something in Word, then it goes back to Word, goes to PowerPoint, Outlook. So very, very realistic. And frankly, the world runs on Office 365. I think those Office drones of us know Office does matter to a lot of IT departments. So best performance here overall is Snapdragon X. And I will say Handbrake as well as Chrome, those are native applications, and Microsoft has made a big push for ARM, and Office 365 has been optimized for ARM as well. But, it's not a huge win. You're looking at maybe 3% over Ryzen, and you're looking at maybe 9% over Meteor Lake for Office overall. But when you get into the subscores, you can see the advantage that Snapdragon has is a lot of it's in Word, where they're about 7% over Ryzen. And then when we get to Excel, it's about 3.4%, which is a little bit of surprise here because Excel generally does favor all core. Some of it, though, is very much just simply responsiveness of Excel itself. Depending on what you're doing, it just simply depends on what the benchmark has chosen to do that maybe perhaps favors one chip over the other. I will say Office 365 predates the introduction of ARM. Office, well, it predates most of the, it predates Snapdragon X anyway. So I wouldn't say they planned ahead for this. PowerPoint, interestingly, Ryzen does the worst here, where we're basically looking at Snapdragon and Meteor Lake essentially dead even, but you're looking at a 9% advantage for Snapdragon over Ryzen here. Bit of a surprise. So I don't know what it is with Office 365, but it does seem to favor basically Intel and Snapdragon at this point, unless you get to Outlook. And frankly, Outlook could use all the help it can get. And the best performance is Ryzen, where it's about 13% of ahead of Snapdragon and roughly 24% ahead of Meteor Lake. So frankly, you could probably pick your poison on where you need your most performance. And I think I might want Ryzen just to get that better Outlook performance. But again, if you are going to use Word, Snapdragon has that lead. But again, I don't think you're going to feel this. Yes, they are on paper faster, but you could guess that basically all these chips are going to give you top-notch performance. But obviously for Outlook, a little bit snappier for Ryzen, a little bit snappier for Snapdragon in Word, and basically PowerPoint. Intel and Snapdragon are going to be kind of dead even. Okay, let's keep going. What's next? Oh, okay, this is a fun one. This is basically an Excel esports competitor made this benchmark for me. It's actually based on his own work, where he basically took an actual spreadsheet he made when COVID first came down. It's a really intensive, huge spreadsheet that goes through tons of databases and very, very advanced real-world work that, again, somebody who is an Excel expert, truly Excel esports competitor, probably wears one of those jerseys that has Excel on it. And he basically made this so if you press the recalc button, because it again is a huge, huge spreadsheet with touching many different parts of Excel that are way beyond me, way beyond even the most advanced Excel nerd I'm sure you know. And at times how long it takes for it to recalculate that spreadsheet. It can be a little sensitive to the versions of Excel, but the version here is basically the same for all of these. And the winner, again, shorter is better because you want that Excel spreadsheet to recalc in less time. The winner is Ryzen with 12 cores. Again, Excel, when you're doing a recalc, generally favors more cores. And this spreadsheet also uses a ton of RAM too. So the winner is a Ryzen to the tune of about 10% less time than Snapdragon and about 9% less time than the Meteor Lake part. So overall, win for Ryzen 9 HX 370 here, again, because it has, I guess, those Ryzen cores simply outgun the cores in that Core Ultra 7. Yes, we want to see Core Ultra 7 here, or Core Ultra 9 as well. But overall, the lead goes to Ryzen in a very, very intensive Excel spreadsheet. So it looks like if you are going to be an Excel competitor and you want a 3-pound laptop, you probably want Ryzen HX in the Ryzen AI HX in there, 300 series. All right, let's keep going. This is something very practical. This is Adobe Photoshop 25.9 using Cinebench 1.0. It basically runs Photoshop through a script and testing it through various tasks in Photoshop. This is great because everybody uses Photoshop. Everybody likes better performance in Photoshop. Bigger bar means better performance. And the win here goes to Ryzen 9 HX 370, basically at 7432. It's coming in about 8.3% faster than that Snapdragon and about 16% faster than that Core Ultra 7. So decent win for Ryzen 9 HX. And one caveat I want to point out is you can go, if you want to go watch my Snapdragon X video, I did run into some weirdness in Photoshop on the native version of Photoshop for ARM, but it got a little weird. So I'm not so sure the performance of the Snapdragon X Elite is quite well deserved there, but still I didn't see the weirdness with Ryzen 9 HX370, and basically it's the winner here. So let's keep going though, because if you're looking at only the top score, that's not enough, because Cinebench actually gives you a lot of different sub-scores telling you what exactly it is basing its scores on. And for overall, the winner for general score goes to Ryzen 9 with about a 4% advantage over Snapdragon, about 14% over Core Ultra 7. And when you're looking at the filter scores, again, Ryzen AI 9 wins again, about 23% over Meteor Lake. Core Ultra 7, yes, we know Core Ultra 9 exists. I wish I had one. Don't have it, unfortunately, and I'm not sure people are really happy to be sending out Meteor Lake in this day and age at this point anyway. And about 17% over that Snapdragon part. And if you look at the other scores here, it actually shows you in seconds how long it took to complete these tasks. This is an average of 3 runs a piece of these. And you can see, it's not always a win for everybody. There's actually some clear wins. Again, like for filter open, Snapdragon is technically faster, but you're looking at 1.3 seconds over 1.5 for Meteor Lake, but it is dead even with Ryzen 9. In fact, a lot of these scores, Ryzen 9 actually does really well against Snapdragon X. There's a huge one there where you're looking at resized to 150 megapixels. Meteor Lake soundly thrashed the Snapdragon part there, and the Ryzen chip is actually even a little... Oh, great, thank you, sorry. Let's put those notifications to sleep. You're looking at a sound thrashing also by Ryzen against that Snapdragon part. But a lot of these are not big differences. Again, if you're looking at select subject, the winner is Ryzen 9, but you're looking at 3.1 seconds versus 3.4 seconds versus 4.6. I probably wouldn't lose too much sleep over that. I don't think that's a huge deal, but still, that's still the winner is for Ryzen. Select mask, again, you're looking at 4 seconds for Ryzen versus 3.7 for Snapdragon. Not a huge difference. Still the winner is Snapdragon. Keep going. Smudge tool, again, Snapdragon does better there. And again, let's say that Adobe has made a native ARM version of Photoshop for Windows on ARM, and this really could be, you're seeing some of this is the performance of Snapdragon. Some of this also could be simply, Adobe did a better job writing smudge tool for Windows on ARM than it did for x86 Windows, right? We don't know. But when you get to adaptive wide angle, though, solid win for Ryzen, taking 62 seconds versus 78 seconds for that Snapdragon part. And even worse is that Core Ultra 7 up at 92 seconds, 91.8 seconds to do that adaptive wide angle filter. And again, camera raw, basically dead even. Lens correction, Snapdragon wins. There's a lot of again, there's some wins for Snapdragon. There's some for Ryzen. Not a lot for Meteor Lake, though. But, and I would say the things where Meteor Lake probably would outpace Snapdragon. Ryzen is basically outpacing it here. But, like, for example, let's look at a good win here. Where is there a good win? No, a lot of these are Snapdragon. Again, like for filter save. Again, there's something with those. It looks like things that are just filter save is something that really, really runs well on Snapdragon. Not exactly sure why. But, Ryzen 9 does outpace Meteor Lake and file save. Again, Snapdragon a little bit ahead. And but, Ryzen not too far behind, but Meteor Lake definitely the third. Clearly, still the overall, when you compute up all the scores, the overall winner is for general score is the Ryzen 73 versus 70, fairly close performance. But when you're looking at the filter score, the way that Cinebench weighs everything, 75 versus 64 for the overall filter score. So overall, Ryzen 9 has the edge over Snapdragon X as well as Meteor Lake in the Core Ultra 7 trim. All right, let's keep going. What's the next benchmark, Gordon? Okay, Lightroom Classic. This actually I'm revisiting because I thought it was really worthwhile You can go back and look at my video on the Snapdragon performance, because I had read that Snapdragon performance was simply terrible on exports of JPEG. So I tried to reproduce that. And I was quite shocked because my Snapdragon X Elite outperformed Meteor Lake in the Core Ultra 7. Again, both very similar class, weight, laptop size. Ryzen 9 HX 370, though, tells me that maybe there's something with the configuration of my Core Ultra 7 155H, or simply something with this version of Lightroom Classic that just does not run really well on Meteor Lake, because it's simply slow. Because it's not, looking at this, you would think, well, maybe it's x86 versus ARM, but no, because using the exact same Adobe Lightroom Classic 13.3.1, I exported 500 JPEGs, and the overall winner is Zenbook 16 Ryzen 9 HX 370, taking about 20% less time to export those 500 JPEGs in the Snapdragon, in a whopping 63% less time than that Core Ultra 7 155H. So I'm not sure what's going on. Is it generally, I find that Lightroom Classic exports like Core, a lot of Core, but also the actual IGP matters too. So this really just simply could be maybe the ARC drivers for this version just kind of stinky poo and it's terrible. But I'm going to dive into the Meteor Lake performance, because I would have expected similar performance, or at least much, much closer performance. Because when I looked at it with Snapdragon X Elite, it's like, wow, even though Snapdragon X Elite is supposed to be pretty bad, it ain't that bad. And again, this is emulated performance, not running native. But what it really tells me is Meteor Lake and ARC, possibly with the drivers in the laptop, just simply do really poorly. It also could be something that doesn't like ARC, or something that does not like Meteor Lake. I'll have to find out. But the real winner here, of course, AMD only cares about, because Ryzen 9 HX 370, soundly comes in faster than that Snapdragon X Elite, and easily, of course, thrashes that Core Ultra 155H. And the next one, of course, is the same thing, except I'm using 100 RAW files. These are older Canon RAW files to export. And again, you're seeing x86, although you would think we get a little more performance when you're looking at 12 x86 cores versus 12 Snapdragon ARM cores emulated. You think it would be better for x86 and Lightroom Classic, but yeah, it's still faster, 8%, whoop-de-doo. I really thought Snapdragon would lag behind that Ryzen 9 here far more, but it's actually fairly close. Of course, Meteor Lake pulls up a little closer, but it's still 30% less, takes 37% more time than the Ryzen 9. So Meteor Lake is the loser here. But again, yes, we know Intel fans, Core Ultra 9 is out there too, higher TDP and all that. But this does show off a little bit better for at least x86, thanks to Ryzen 9 HX 370. But let's keep going, because we got more benchmarks, folks. We got more benchmarks. Okay, this is a fun one. And of course, it's fun because I would have run this when I did Snapdragon X, but it does not run on Snapdragon X. And I realized one of the problems when you're looking at the Windows on ARM world is you generally tend to run things that run. Because if you're looking at basically putting a 0 or DNF or DNS, did not finish, did not even start, you just simply don't run it, because what's the point of showing it if you can't even run it on Snapdragon X Elite? Well, maybe the problem with that is it sort of bends gravity towards Snapdragon X Elite, because you think more things run on it when a lot of things simply don't, such as Topaz's Gigapixel AI. This is essentially a imaging application that uses AI model-based upsampling to increase the resolution of your JPEGs and image files. So you can take low resolution pictures and increase them 2x, 4x, 6x, and they look quite wonderful most of the time. As we know, AI is not perfect, but honestly, it looks beautiful. And this is a perfect example for me, because what I'm doing is I'm taking, I believe, 5 JPEGs that I shot on a Canon 1D 1D Mark IIN, an 8.2 megapixel camera, I don't know, 12 or 13 years ago. And that's exactly what you would go like, gosh, 8.2 megapixel sounds ridiculous in the age that we're in today. And I would like a little more megapixels. So I can feed those images into Topaz Gigapixel AI and end up with a 4x upsample of my images, basically getting me up to about that 32, 33 megapixel range on those old images. And they are going to look far better than doing, conventional upsampling using, all of the various methods that we've used before, because AI for upsampling is pretty impressive. Check it out. Topaz has demos you can go download and run. So again, I feed those 5 images into it. I'm doing a 4x upsample using the CPU. You can actually, of course, do this on other things, but for this, I wanted to look at the CPU. And again, Meteor Lake is not looking very pretty here. And yes, I know there is Core Ultra 9 out there. There is 185H, but I'm not sure it's going to close this margin up because it just simply was not pretty here running on the Core Ultra 7 155H, doing the upsample on the CPU. I don't know if this is the magic that AMD has been rubbing in Intel's face, but it potentially could be, because Gigapixel AI 7.3.0 uses AVX2, AVX, possibly even AVX 512, and VNNI, a lot of stuff that Intel has been pushing for a long time. In fact, Intel did a lot of the work early on to get Gigapixel up and running using VNNI. So it was something that classically, when I ran this, 5-6 years ago, Intel chips, Tiger Lake, would easily smush the Ryzen chips of their age. But we're looking at a huge difference. And you have to run this upsample multiple times. It is just simply painful to do on Meteor Lake at 1,624 seconds. So it was no fun. I actually ended up pulling some of the images out. I had more images, but I didn't want to wait for Meteor Lake to finish it because it was just simply painfully slow. But Ryzen 9 HX370 took only 403 seconds to do the upsample here on that 7.3.0 on the CPU base. And it simply crushes Meteor Lake here. I probably should go and run this on Raptor Lake and maybe a couple other Intel architecture chips just to see what the hell's going on. But when you're looking at the best and brightest from Intel and AMD right now, and Snapdragon, because you got to figure like, hey, I want to run Topaz products on Snapdragon. Not today, ain't going to happen. You're going to want Ryzen 9 HX370 because it just simply outpaces it pretty handily here. So one thing I just realized is I actually fubbed up the Ryzen name of the Ryzen chip. It is actually the Ryzen AI HX370. I forgot to put it in the model number in my Excel spreadsheet. Sorry, but I'm well into this and I'm not going to go ahead and re-record this. So I apologize, AMD, because it is the Ryzen AI 9HX370. Just rolls right off the tongue, doesn't it? Makes me appreciate Snapdragon X Elite X1E 80-100 at this point. And frankly, Core Ultra 155H is actually pretty easy to understand. But anyway, we're going to say Ryzen AI 9. I'm going to try to remember to say this on the far out. So anyway, you can also run Topaz Gigapixel AI if you have graphics. And, arguably, if you had a GeForce or Radeon discrete graphics, why would you run it on the CPU, especially if it's so slow? I would probably agree with that. But I did run this on both the IGPs, basically running it on, of course, Radeon, as well as on ARC graphics. And the winner is Ryzen AI 9 HX370 with its Radeon graphics. But not, again, the nice thing is it closes up at least the problems that Topaz Gigapixel AI has with the Meteor Lake chip. Doesn't seem to affect ARC graphics because it's actually pretty close here where you're looking at maybe 16% less time to finish our upsample, which is not bad considering the thrashing it got when you only use the CPU cores in the Core Ultra 7 versus that Ryzen AI 9 chip. So, of course, both of these would laugh at Snapdragon because it does not run at all on Snapdragon, period. So hopefully one day Snapdragon X can get into this game, but today, not there. And just a reminder of why some people may want x86 over ARM-based Windows laptops. All right, let's keep going. All right, up next is PCWorld 1.0 running Adobe Premiere Pro 24.50. I'm not so sure people would run. Let me restate that. I would say classically, I would probably never run Adobe Premiere Pro on a laptop with integrated graphics because it's usually just pure suckage. But let's be honest, with how Intel and AMD have really pushed performance on integrated graphics, I would say we're actually to the point where you might want to run Adobe Premiere Pro on a laptop without, discrete graphics, without Radeon discrete, without GeForce discrete. And we're kind of there. So I did want to run it just to get a feel for it. So again, I ran it on the Ryzen AI 9 HX370 chip, as well as on the Core Ultra 7 155H. Core Ultra 7 155H has ARC graphics, and the Ryzen AI 9 HX, of course, has the latest Radeon graphics as well. And bigger bar is better, and the winner is the Ryzen AI 9 at 3428. Basically, score about 20% faster than the Core Ultra 7. Nice showing. And again, yes, I know there is a Core Ultra 9, which, probably would close this up a little bit more, especially in a little bit of a bigger laptop. But this is not bad when you're considering integrated graphics laptops of 5 to 6 years ago, where you would be insane to even think about running Premiere Pro, where we're actually getting to the point where this ain't bad. This really ain't bad. And of course, I did include that 0 here for that Surface Laptop 7 with the Snapdragon X Elite because there is no Premiere Pro for Windows on ARM yet. It doesn't seem to run easily. Emulated, people have tried to do it, but it's a pain in the butt. And why bother? Because it's just not going to be great. So we'll have to wait for the ARM version of Premiere Pro to come out. Adobe has said they are working on it. But today, if you're going to try to do it, and especially if you're going to try to run Cinebench, you're going to get a great big fat 0. So I think it is something worth pointing out because I do think Intel and AMD got kind of sore because a lot of the Snapdragon X reviews tended not to use applications that did not run it well or run it all on Windows on ARM, which does tend to bend gravity a little bit towards those ARM-based laptops. So I decided to run that just to give you it. Let's dive into the sub-scores here because there is more with Premiere Pro that Cinebench gives you. And for the most part, diving into the sub-scores, the performance of the Ryzen AI 9 is handily above the Core Ultra 7. You're looking at about 40% in the long op score, about 26% in the inner frame score, 14% in the raw score. The GPU effect score, though, sees them close up pretty closely. I'd say dead even. Technically, Radeon's and Ryzen AI 9 are about 9% faster, but let's face it, that's pretty damn close. So, but overall, solidly the advantage seems to go to Ryzen AI 9 over the Core Ultra 7 here. But there's even more because Cinebench spits up even more details in the overall score. If you're only looking at the overall score, you're missing a little bit about what you're getting out of Cinebench because there is more to take in. Okay, here is the actual individual scores that the overall and those sub-scores are based on. This is basically the actual measurements of the encodes and the processing and GPU effects measured in frames per second. For the most part, again, there's a reason why the Ryzen AI 9 wins everything because, look, you're looking at 61% in the H.264 encode. You're looking at 70% in the HEVC encode. You're looking at 58% higher frame rate in the H.264 encode. and you're looking at 46 more frames per second in the HEVC 50 megabit encode. So overall, for the most part, Ryzen AI 9 is a solid winner across the board. That isn't true everywhere, though, because if you look at that 4K ProRes, surprise, surprise, the Core Ultra 7 actually outperforms the Ryzen AI 9 than the Radeon and the Ryzen AI 9, to the tune of about 18% in 4K ProRes 422, and if you're looking at 4K ProRes 422, about 14% faster there as well for Core Ultra 7. So that's of course really funky to me because if you don't know, ProRes is a codec developed by Apple. It is firmly something that Apple has an advantage of because they developed it, they evangelized for it. They also don't tend to share the secret sauce in ProRes, so that's why Apple products, Apple laptops tend to easily outpace Intel and AMD laptops because they have a really big advantage in ProRes, and it shows up there. But when you get to that DNX HR, we get back to Ryzen AI 9 outperforming the Core Ultra 5, 17%, 17%, 17% for Red. And when you're looking at the GPU effects, though, we actually close up pretty closely where Core Ultra 5 and Core Ultra 7 and Meteor Lake dead even with the GPU effects and Lumetri color, and Gaussian blur fairly close as well as the sharpen is fairly close. So for GPU effects, they're actually fairly close between these, but encode firm advantage for Ryzen AI 9 over that Core Ultra 7. Again, I would love to see the Core Ultra 9 here to see if it closes up a little bit more, but generally for a lot of these codecs, Radeon and AI 9, Ryzen AI 9 are doing better, except when you want to get to ProRes, where Intel is outperforming AMD in Apple's codec, which is kind of funny to me. So, but let's keep going because we still got a few more things to cover. We're almost at the end, though, and this is something I really did not cover with Snapdragon because we left that to more game coverage on the website on PCWorld. Adam was also looking at some Snapdragon gaming performance, I believe, in a video that will be upcoming. But I figured you can't look at Ryzen AI 9 and Radeon 890M graphics without looking at actually graphics performance, because that has been one of the things that AMD has been just simply crushing everybody in. You can see that in all the handhelds. First, we're going to kick this off with the UL 3D Mark. This is TimeSpy graphics. Everybody's familiar with it. It's been out for quite a while. It's a DX12 benchmark. It's a synthetic benchmark. It's not actually based on a game, but it is pretty much a great way to measure graphics performance, and it doesn't really change because the performance you're seeing today will probably be the same you're going to see if you go back and you rerun it 5 years from now, because things don't move. Everybody really also does a lot of optimization here, and you can imagine that Intel's done quite a bit of optimization, and Intel Arc in the Core Ultra 7 155H in graphics performance is actually outperforming the Ryzen AI 9 HX 370 with the Radeon 890M to the tune of about 8%, which is not bad at all. You got to give it to Intel here. They clearly have done their optimization for TimeSpy graphics, and technically they're ahead in TimeSpy graphics. And of course, they're both well ahead of the Snapdragon X Elite and the Surface Laptop 7. And I will say I considered not even showing a score for the Snapdragon X Elite X1E80 because it was very crashy. It took many, many runs just to get one score out of it in 3D TimeSpy graphics. It just simply kept crashing on me. But this is one of the scores that I got out of here. I kind of gave up after that, but I thought I'd put it in here just for a point of reference. AMD's got like 91% more performance than the Snapdragon X Elite. So Adreno graphics and Meteor Lake Arc graphics, 106% performance, and that's only if you could get it to complete that run. So this is something that Snapdragon X Elite is not great in. Adreno graphics has been kind of one of the weaknesses here on this new chip launch. And Intel Arc and AMD Radeon 890M would like to send you a message, Snapdragon X Elite, and that is you need to get it in order. Okay, up next is something newer. This is 3D Mark's Steel Nomad. Unlike TimeSpy, which is not actually optimized for ARM-based chips, which is why it kind of just stinky poo for the Snapdragon X Elite. Steel Nomad Lite is newer. It also does run on ARM. It also does run on x86. It doesn't really change the fortunes on Snapdragon X Elite that much, though, does it? Because you're looking at, 55% more performance out of the Zenbook S16 with that Ryzen AI 9 HX370 on the Radeon 890M graphics, and essentially the same thing. Basically, again, out of Core Ultra 7 with 55H in the Arc graphics. Again, Arc and Radeon would like to send you a message, Adreno, and that is you ain't got nothing on us, right? Okay, these are synthetic benchmarks, and I know a lot of people don't like synthetic benchmarks, but I still actually like 3D Mark because they're very reliable. They also give you an indicator of what things could be like in a perfect world. But of course, gaming is not there. We know gaming is not perfect at all. It touches the CPU, it touches system memory, it touches many, many different things. And synthetic benchmarks don't also always tell you what exactly you're going to be getting out of actual games. So let's do a few games. And we're almost at the end here. I just want to let you know. Okay, Cyberpunk 2077 running at 1920 by 1080 using the low preset and FSR 2.1. I also did try it for XeSS for Intel, but basically about the same. It didn't really change the Arc graphics fortunes that much. And Surface Laptop 7, basically dead even with the Zenbook 14. Core Ultra 7 155H with Arc graphics, essentially dead even in Cyberpunk 2077 and Snapdragon X Elite with Adreno graphics. And, that's probably, you could guess that Intel has really optimized Arc graphics for Cyberpunk. And also, because of the high profileness of Cyberpunk 2077, you can imagine Qualcomm has probably also highly optimized Adreno graphics for Cyberpunk 2077 as well. But of course, AMD and Ryzen AI 9 HX370 and Radeon 890M would like to send both of you a message, and that is, you still stink. We're ahead of you to the tune of about 57% or 58 frames a second to your 37 frames a second. So you got a ways to go. Adreno and Arc graphics is what AMD would like to say. So despite the synthetic graphics saying these are actually somewhat similar between Arc and Radeon 890M, the actual games would say no. And this is in Cyberpunk on low. Yes, I could crank it up a little bit more, but that's just going to slow down those other chips. And frankly, I don't think people are really going to be playing 2077 on any of these on much higher than low. I did try running it on Steampunk using the Steam Deck setting, but it crashed out on the Snapdragon X Elite, so I decided to go to the low setting, which ran on that, and I ran that across all three platforms. Okay, let's keep going. Not a lot of gaming stuff because, frankly, I think we're going to get the gist of where it's going. Next up is Shadow of the Tomb Raider. And again, this is something that shows really well for ARM, Windows on ARM, because it is something that Apple shows off. It's something that also Qualcomm has showed off because, hey, it runs it pretty well. And honestly, when you're running a game emulated, that's really not bad. You got to say 30 frames a second out of Shadow of the Tomb Raider, 1920 by 1080 on the low preset. That ain't bad at all. Unless, of course, your Ryzen AI 9 HX370 with Radeon 890 graphics, or if you are also Core Ultra 7 155H with Arc graphics. They would like to say, no. Actually, no, your 30 frames a second is not that great, Snapdragon X Elite. Of course, the winner is the Radeon 890M with the Radeon AI 9HX 370, 64 frames a second versus 50. That's basically 28% higher frame rates out of that Zenbook S16. And when you're comparing these Ryzen AI 9 HX370 to the Snapdragon X Elite in the Surface laptop, you're looking at a whopping 113% higher frame rates out of that Ryzen HX370. So yes, again, I know that the thermal performance of the slightly larger Zenbook S16 might be at play here, but I suspect if we go to a Surface Laptop 7 and the larger 15-inch or other laptops we're seeing it at, it's not really going to be touching the S16 with the new Ryzen AI 9HX370 either. So, all right, last gaming benchmark is something fairly easy. This is Tom Clancy's Rainbow Six Siege. It is basically an older game, but a very popular game. Also, popular because it runs on a lot of hardware these days. And frankly, it's giving you really impressive performance. And I would say I am very impressed because I would usually say, well, I would not recommend playing games on integrated graphics. But the Zenbook S16 and the Ryzen 9 HX370, Ryzen AI 9 HX370 has kind of got me reevaluating my take on that because 154 frames a second in Rainbow Six Siege at medium with the medium preset. So that is a 50% render by default, but still 154 frames a second is really, really playable. Even somebody who actually is looking to actually get a decent KD ratio out of one of these IGP laptops. And honestly, I would say it's not bad either for Core Ultra 7 155H and Art graphics at 127 frames a second because that is not bad either. That's really not bad. I mean, yes, the Ryzen AI 9HX is still about, 21% higher frame rates, but I would say both of these are very, very playable. So I would say I may have to eat crow on never recommending integrated graphics laptops for somebody who wants to play games, at least sort of more casual games. But this is really an esports game where you really need high frame rates in order to get, to be at least competitive in a game and not just simply be suckage. And of course, I definitely would not recommend the Snapdragon X Elite. Yes, it is cool. You can run this game emulated, but when you're looking at 38.7 frames per second, or basically 300% higher frame rate out of the Ryzen AI 9 HX370, I just don't think it makes a lot of sense. Yes, it runs, and I would say that most people are going to be playing a game like Rainbow Six Siege in the 30 frame per second range, are basically going to be just fodder. You're basically there for somebody else to easily eliminate in the beginning of the match because that low frame rate's just simply going to hurt you, especially in a game like Rainbow Six Siege. So, but in general, you can see that Ryzen AI 9 HX370 on the Radeon 890M is likely going to be the tops in graphics performance that we're going to see right now. Art can get fairly close in some games, depending on the game. But overall, I would say from what I've seen so far, Radeon 890M does not disappoint in the Ryzen AI 9 HX370 part. Arc, not bad, but still looks like the overall performer is Ryzen, and Snapdragon X Elite is still, I think, not recommended for gaming. I think I've said that before. It just doesn't make any sense, especially in the premium laptops that it's in. But you can play some games. The fact that we actually can run these games at all in an emulated mode is pretty cool. And yes, you can do it. I don't recommend it, though. In fact, basically, I would recommend Ryzen AI 9 or obviously Core Ultra 7 or Core Ultra 9 over the Snapdragon X if you really want to at least play some games in a casual manner on an IGP Lite laptop. Okay, but let's get into the very last thing, which is something that is important, and that is battery life. And for that, I'm using UL Procyon. You have seen this before in the Snapdragon X review that we did on the YouTube channel. And Basically, what it does is it takes Office, it takes Word, Excel, PowerPoint, Outlook. Again, it multitasks, it fires them all up. It's running all of them at the same time to simulate what would happen if you were to sit there running Office on your laptop continuously. One thing I want to tell you is it's kind of a lazy person's benchmark in that it simulates a lazy person because yes, it has Word, Excel, PowerPoint, and Outlook running. They're all running at the same time. It alt tabs between them, but it's not the kind of person that's going to sit there and going to be like, I'm going to be in this Excel spreadsheet and in this PowerPoint for 80% of the hours of the day. This is actually your coworker who fires up all these Office documents on their laptop with the software. The IT department has them monitoring to see if they're actually using these documents, these Office applications, and then they go to their TV and they watch a Netflix show because there's a lot of goof off time. Yes, it is running these applications. I've actually tested it. The actual SoCs are bumping up to power, 18, 20 watts, 25 watts at times. And then they basically go to idle for 20 minutes for an entire episode of Brooklyn Nine-Nine. So they can watch an entire episode of Brooklyn Nine-Nine, and then they come back and they work for a little bit. And then they walk away and they watch another episode of Brooklyn Nine-Nine. So a lot of goof off time, but, again, it is realistic. The last caveat I need to put out here is battery benchmarks are very difficult. Battery life benchmarks on laptops are different because you can never get the same laptop. You can't get the same screen. You can't get the same battery size. In fact, we have significant battery size differences here. The Surface Laptop 7 has a 56 watt hour battery, I believe. I better make sure that's right. It has a 54 watt hour battery, whereas the Zenbook 14 OLED has a 75 watt hour rated battery, and the Zenbook S16 has a whopping 78 watt hour battery. That basically is a 44% larger battery in the Zenbook S16 and about a 38% larger battery in the Zenbook 14 OLED than the Surface Laptop 7 with its 54 watt hour battery. But, okay, hey, that's a significant difference in battery size between those laptops. But the last thing I also need to point out, which again always gets to the imperfectness of any laptop battery rundown test, is the screens matter. Yeah, I could run them on external displays. It gets all kind of weird and funky, but the Surface Laptop 7 has a 13.8-inch IPS panel, and the background color really doesn't matter whether you're using white or dark or gray. It doesn't matter that much. However, on the Zenbook S16 with the Ryzen AI 9HX and the Zenbook 14 OLED with the Core Ultra 7, those are both OLED panels. And if those panels are on solid black backgrounds, they don't consume as much power. If they are on very bright white backgrounds and light colored backgrounds, they use considerably more power than they do when they are on black or dark backgrounds. And this is the problem with the UL Procyon Office test. I still think it's valid, but it does default all the applications to the white background of Office applications. So PowerPoint and Excel and Word are on white backgrounds. And when you have OLED, it just simply consumes quite a bit more power than it does over an IPS panel. In fact, if you look at the published specifications from a lot of these Snapdragon laptops, the OEMs that have OLED panels have a significant difference in battery life over the ones that have IPS panels. So, with that said, OLED is a major drag on both the Ryzen and the Core laptops. However, they also have significantly larger batteries. So, how does this shake out? In the end, the winner is, of course, Surface Laptop 7 with the Snapdragon X Elite. Basically giving you, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, in excess of 12 hours of well-running Office 365. And again, this is not just simply running video, because if you were doing a video rundown, it could be 25 hours for all we know, because video is extremely easy to run. Running Office and actually doing things, even though it's from your goof off coworker, still uses more power than most of those actually video rundown tests. And from the Zenbook 14 OLED with that Core Ultra 7, you're looking at just over 10 hours, which is a little bit less than the Zenbook S16 with its Ryzen AI 9 HX370, which is slightly better, but you're still looking at basically dead even with that Core Ultra 7. So basically both of those laptops giving you about 10 and a half hours in Office 365, whereas the Snapdragon X Elite gives you just over 12 hours. So, Snapdragon X Elite with ARM, definitely with an IPS panel and that smaller battery is definitely, it's living up somewhat to the claims of giving you better battery life. Not the sort of magic bullet I think some people would have hoped it would. And, honestly, I'd be pretty happy if I got 10 and a half hours sitting there in Office all day. And again, this is not going to sleep. This is the screen always on, running Excel, Office, Outlook, Word. Even when you're goofing off, the screen is still on. It doesn't blank off. So this is decent battery life from all of these, but the winner is still number one, Snapdragon X Elite. Number two, but not that much, is Ryzen AI 9 HX370. Still pretty decent performer. And then Core Ultra 7 is slightly less, but not a big deal. And of course, you do have a bigger panel, OLED panel in the S16 than the Zenbook 14 OLED, but I wouldn't be unhappy with any of this. But ARM definitely giving you that better battery life, especially when you're still looking at, a 40% larger battery in that S16. But I would not be unhappy with that Ryzen AI 9 HX. So there is one more thing I need to point out, though, and that is UL Procyon, besides actually giving you the actual runtime, it actually gives you performance responsiveness, basically looking at, well, not only do we care about how long you're going to run a battery, we want to know how it's going to respond, sort of that snappy or crisp feeling that you're going to get out of your laptop when you're using it on battery power, which is this. And that's represented by the performance. So this is actually the median performance of all three laptops. Bigger bar is better. And you're basically getting 201,000 versus 101,000, which is the worst out of that Ryzen 9 HX370, and 121,000 out of that Core 7 Ultra on battery. So what does this mean, Gordon? Basically, if you're on that Snapdragon X Elite, in general, it's just going to feel a little more responsive. The windows might pop up a little faster. Applications may launch, faster than on the Core Ultra 7 or the Ryzen AI 9. And why is that? Well, for this test, I'm running them all set to balanced and recommended for the Snapdragon X Elite, and both the Ryzen AI 9 and the Core Ultra 7 are set to Ryzen or to balanced power. And what's clear to me is the OEMs, because a lot of this is a choice of the OEMs, have decided to basically back off the power. So you know what? You really don't need everything to, be extremely responsive like you are plugged into the wall. And if you do that, you're just going to eat more power. So what it looks like is both Zenbooks have essentially decided we are going to back off those high clocks in order to give you better battery life. And that comes at the cost of less responsiveness versus the Snapdragon X Elite, which is simply going to be snappier most of the time. So that's just simply the reality of the UL Procyon test. Unfortunately, though, we're going to end our testing here because there's a lot more to talk about, a lot more testing to do. This first video will only look at the performance of the graphics, the CPU performance of the Ryzen AI 9 HX370 versus the competitors. And overall, I'm going to say pretty good. Gaming is excellent as we expected. And overall, the 4 cores plus the 4 compact Zen cores are really, really doing really well, giving you actually performance on par with content creation laptops, which I did not expect, and also easily beating the Core Ultra 7 in the smaller frame laptop, as well as the Snapdragon X laptop. I will get into more of the power consumption of Ryzen AI 300 series as I have more time to look at it, but performance, right, exactly. I think probably where it's been marketed, it is looks like it's the current leader for performance overall, and that's on CPU performance as well as on graphics performance. On power performance, AMD really wasn't beating his chest a lot here, and it looks like Snapdragon X still has an edge, but we're going to get more into that when I actually can sit down and do my practical real world tests of all three laptops. That does take quite a bit of time to set up and run, but when I have that video ready, you will be able to see that right here on PCWorld's YouTube channel. Please come here, as well as going to PCWorld.com for more in-depth reviews of all the cool hotness in the PC world. Gordon out. See you next time.